of an earthquake that measures, oh, since we're bringing it up, an 8.3 on the Richter scale. Okay? You still have the same formula, but this time, where are you plugging in a number? I'm thinking of a number. And
8.3 equals the log of, you don't know what, over,
that's 0. That's the formula, right? Okay. I know, wait, we did. I know it's been a couple days since we did this, but we did solve some log equations. Does anyone remember the trick that we used to solve some log equations so far? We went from log form to exponential form. And if I were to rewrite this in exponential form, what would be my base?
10.
This is understood base 10, right? 10 raised to what power? What's my exponent? Is it this or is it the 8.3? 8.3 is my exponent, right? So 10 to the 8.3 power is that unknown intensity divided by I sub 0. So I, the unknown intensity would be 10 to the time, 10 raised to the 8.3 power times whatever that minimal sort of intensity would be. And on my calculator, if I do 10 to the 8.3 power, crap. It's big. I'm getting almost 200 million, if I'm counting correctly. Are y'all getting 200 million-ish? Yeah. That's how strong it is. It's about 200 million times stronger than that I sub 0, whatever that turned out to be. That does sound strong. Okay, well that was fun. We're not going to go into this in detail, but I do want to say there are a couple other things that are logarithmic scales. Sound. You know that sound is measured in decibels. Decibels are a log base 10 system. What was the other one? Oh, some of y'all have taken some chemistry, and you talk about acids and bases. And when you talk about acids and bases, you measure the pH of that, the pH scale. Your pH scale is also a logarithm scale. So these are guys whose formulas are going to use logs and whatnot. Maybe exponents. Anyway, they have formulas that you can look up or you can be given. But it's all going to sort of work the same way. You're just going to plug in the information into the formula and kind of go from there. Okay? So I got like almost 5, maybe a little more than 5 minutes left. Which is funny because some of y'all packed up thinking, you know, this has got to be the end of the lecture. No, we're going to go ahead and write some stuff down for 4.5. And we're going to lay the foundation for that. Now, 4.5 is a biggie. If you had plans to not be here on Tuesday next week, either change your plans or plan on failing the test, okay? Because I like solving equations. And I'm going to give you lots of equations to solve. And I'm not going to pretend like, you can probably just read it and figure it out yourself. It's not going to happen. So, okay, solving log and exponential equations. Finding the values of x and all that stuff. Okay? What we're going to do next week is I'm going to give you a handout. It's got like 9 or 10 equations on it. And what we're first going to do is we're going to identify which kind of equation is this. And there's going to be 3 categories. Okay? So the first family is going to be our exponential equations. We're going to lump all of them together. So how do you know if you're looking at a function, an equation, how do you know if it's an exponential equation? Well, it's an exponential equation if you have variables in the exponent. That's what you look for. Okay, so something like 4 3x plus 1 equals e to the 2x minus 11. Something like that. That would be an exponential equation, okay? And if it's an exponential equation, we're going to have one method for solving. And if I have time, I'll tell you what it is. Next up, we have two kinds of log equations. One kind of log equation is the kind I call log equals number. Okay? If everything on one side is sort of the logarithm equals a number on the other side, then we've got a log equals number kind of equation. They don't all come in this form. We may have to do some manipulating and whatnot to get there, and we'll spend some time next week talking about that. But this is something like the log base 3 of x squared plus 2x plus 1 equals 7. This is the log of something equals a number. Okay? The other kind of log equation is actually the easier one. Oh. What if I get it to say log equals log? Then that's a different sort of deal. Okay? So this is like the natural log of x plus 4 equals the natural log of x squared minus 3x plus 1. Okay? Where the log of this equals the log of that. Okay? And these are going to be our three types of equations that we're going to solve. I'm going to give you a strategy for solving each one of these guys, and they're going to be different strategies. Okay? It's not like this is essentially the same thing as this. We actually are going to play these guys pretty differently. All right? How much time do I have? 3 minutes. Okay, so two more things I'm going to say. If we have exponential equations, the strategy that you guys are going to use are take either the common log of both sides or the natural log of both sides. Okay, either one. You're allowed to do that, although I would strongly recommend you do natural log if you have base e. Okay? So we probably won't solve this equation. I've got some other equations for you next week. But if I was solving this equation, I would probably take the natural log of both sides. Why would I pick natural log? Because it's going to cancel with my base e. The natural log here is going to cancel with the e, and I'm just going to be left with 2x minus 11. Otherwise, I'm going to have to do some other stuff with exponents and things, okay? If you have log equals number, then what we're going to do is we're going to rewrite in exponential form. Okay? We're not going to solve this equation, but if we were, that means from here to the next step, I would go base 3 to the 7th power equals this other stuff, and I would solve that equation. All right? The last one, if it's log equals log, then we're going to solve a equals b. What do I mean? If I have the log of a equals the log of b, then doesn't it make sense if the log of this equals the log of this, the stuff on the insides have to equal each other, right? So we would solve whatever that equation is. So here I would solve x plus 4 equals x squared minus 3x plus 1. It's kind of like, I hate saying this, like don't show any other math teacher this, but it's kind of like the logs cancel each other out. Kind of, sort of. But don't tell myself that. All right? Last thing. I still got like 3 minutes, right?
No.
I got like 28 seconds. There you go. That was simple enough, right? Our two log equations, the solutions we get, we're going to have to necessarily check. Okie doke.